Mathematical puzzles are one of the best way to exercise our brains. Not only is the best activity given to children to enhance their logical ability, but also it's a fun activity for people of every age. Given few inputs and few rules, finding out the best and feasible solution is what these games are about. So let's explore one of the mathematical puzzle, the Tower of Hanoi. It's a gaming puzzle having its roots in mathematics. Playing this game involves just your thinking ability and little bit of analytical skills. So let's test our ability to solve puzzles and find solutions to this simple yet brainstorming mathematical puzzle. So stay tuned and enjoy this course. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments. Welcome to the session where we'll be talking about Tower of Hanoi using Java programming. So let's talk about the agenda of the session. So in this, we'll be talking about the mathematical puzzle that is Tower of Hanoi. What is the basic idea of the complete puzzle or the complete game will be discussed, and then we'll see its implementation using recursive programming concept in Java programming language. Now let's see what is this problem of Tower of Hanoi actually, and how is this using the concept of dynamic programming to solve this problem. Okay, so let me tell you what Tower of Hanoi is first of all. So you can say it's a puzzle, it's a mathematical quiz or a mathematical puzzle that involves the concepts of rods and disks. Okay, so in Tower of Hanoi, the puzzle, how it is structured is that there are three rods, okay, and there are n number of disks of different sizes. Now n number, let's take an example three here over here and go ahead with this. That's the general value for n, but you can have more than n as well. I mean more value for n as well, like 4, 5, and so on. So there are three rods and there are three disks of different sizes. Now the puzzle says that what you have to do. So let's try to understand in this way. So there are three rods. So let us represent this AB, tower A, tower B, and tower C. Okay, as the three rods. And there are three discs. As of now, I've taken N as three. So three discs is there of different sizes. Different sizes meaning one disc which is at the lower end, lower side will be the bigger disc, then the smallest after that, then the smaller after that. I mean, the smallest one will be on the top, and then the next bigger will be after that, then the largest will be at the end. So this is how it will be arranged in any one of the rod or any one of the tower. Okay, now puzzle begins with this. This is the initial state for the puzzle. What is the final state or what output you have to, as gain or to solve this puzzle is that you have to move all these three disks from tower A to any one of the tower, maybe let's see tower C. Okay, by using maybe the tower B. Or if you, obviously you have to use tower B, without that it's not possible. So you have to shift all this disk from tower A to tower C, and it should be arranged in tower C in the same order how it is arranged in tower A. That is, the larger disk should be down, this disk should be over here, and this the smallest one should be over here. So the same arrangement should be copied to tower C. And you have to just make use of this particular tower, meaning you cannot remove a disk and keep it somewhere else on no surface. You have to remove the disk from here and keep it in either of the towers only. Okay, and so this is what you do, mix and match, and then finally the final state which you have to achieve out of this puzzle is that in the tower C you should have all the disks arranged in the same way. It can be tower B also, guys. You can shift all the disks from tower A to tower B by using the rod or a tower C. But okay, let's not confuse ourselves and stick to one particular frame. That is, we have to move or shift all these disks from tower A to tower C by using this tower B. Okay, but disk should be arranged in same way over here. Now this is the initial state, final state, you understood. There are some rules to be followed as well. One of the rule I said is you cannot remove the disk and keep it somewhere else. You have to make use of these towers only. Okay, Then another rule is only one disk can be moved at a time. Otherwise, it's very easy, right? You can shift or pull out all the three disks together from tower A, and together you can put it again the same way in tower C. Solved, right? But that's not how it should work. It should be, the rule is says that only one disk at a time can be moved from any one tower to the other. Right? Meaning if you are moving the smaller one, the only smaller one can be moved. Then next one you can move. Then next one you can move. All together, neither two of the together also cannot be moved from one tower to the other or one rod to the other. That's the first, rule. Second rule is that disk should not be arranged at any given time such that a larger disk is stacked over the smaller disk. That is, even though the final state which you have to achieve should be that its disks are arranged in the same way, like larger disk down and the smallest one above it. But not just the final output should be this, but also in the intermediate also, whenever you are stacking two disks, suppose, or three disks in some of the tower, then that two disk or three disk should also be in this order only. The largest one should be down, then smallest one above it. It should not be that the smallest one is down and the larger one you keep it above it. Like you can't do that, move the smaller one over here and then the larger one above this. That should not be there. This should not be the case. That's the second rule. Okay, so disk should not be arranged at any given time so that the larger disk is stacked over the smaller disk. Always it should be larger to smaller in order from the bottom to top. Okay, so following these two rules, you have to shift all the disk from tower A to tower C. So this is the problem statement. Now, what should be the solution to this? To understand the solution, what you should do is, let's see again carefully what I'm doing here. Okay, this will also give you the logic to write the program or a code for this. So it's very important for you to understand and listen it carefully over here. So you can see here, largest one I have stacked down, then this and then this. This is tower A, this is tower B, and this is your tower C. Okay, now I have to move all the disks from tower A to tower C. What I'll do is first I'll move the smaller one into tower C. Okay, so the smallest one, this will be moved to tower C. So I'll be moving the first disk from, so first disk is moved from tower A to C. Okay, from A to C. Smaller one is over here now. This is removed from here. Now after that, what happens is, what I'll do is, I'll move the next smaller, next larger one to tower B. So this one is moved to tower B. Okay, is removed from here and it's moved over here. So I have moved the second disk from tower A to tower B. Understood? Now what I'll do is, the larger one is there. Now all three are having one disk. What I have to do is, from tower C, this is the smallest one. This is the disk one. So this will be moved to tower B now. This I can arrange because this is the second largest one and this is the smallest after that. So this can be arranged over here. Like larger and then smaller, this can be stacked in this order. So this one I will move from here to here. So what I did was, disk 1 is again moved back from tower C to tower B. Getting it? So now tower C is empty. Nothing is there in tower C. Right? I'll draw it again here. Nothing is there in tower C. And tower A is having only the larger disk one and tower B is having two disks. The second largest one and the smallest one. Now what I'll do is, I'll move the disk from tower A to tower C. This is the largest one. So I'll move the disk 3 from A to C. So from A to C, this is moved over here. The largest one is moved over here. Getting it? Now there is nothing in tower A. Now what I'll do is, I'll shift the smallest one over here to tower A. Okay, the smallest one. So the smallest one is again in tower A. So what I did is, disk 1 is shifted from tower B to tower A. Got it? Now this one. So this is shifted, so this is not there now. This one will be shifted from B to C now. Because this is the largest one, this is the second largest one. So the second largest one can be stacked over here. So I have moved the second disk from tower B to tower C. Right? Now the smallest one was in tower A. So now tower A to C, the smallest one will be moved lastly. So from the smallest disk is moved from tower A to tower C. Got it? So you can see finally we have arranged all the disks. Now in tower A there is nothing in tower B also. And in tower C we have stacked the disk in the same order how it was initially arranged in tower A. Okay, so few shiftings were here and there, back and forth, and finally we got this arrangement. So if you see this trend over here, I'm telling you to analyze this trend because it will be easy to write a code for you. So it is nothing but what? Recursive call to shifting of disks, right? Okay. Now this to understand this recursive call, we have to understand this pattern. So you can see here, the first movement of the disk was between A to C. Okay. Next movement was A to B. Then was C to B. So first three, if you see, there was a movement of disk between A and C rod. Next was the movement between A and B. Then was the movement between C to B. Then again was the movement between A to C. Then again there was movement from B to A, or you can say there is a shift of disk from between A B. If I say in a proper way, here the disk shifting was between AC, this between AB, and this one between CB. Again AC, AB, CB. Again AC, and then maybe so on. So there are only three disks, so it stopped over here. But this trend will continue if there are more number of disks. Getting it? So if you analyze this, so these three is again being repeated and then again being repeated. So three times you have to call the functions. Once to move the disk from A to C. Next time to move the disk from A to B, or to move disk between AB. Okay. One time you have to call a function to shift the disk from between AC. Next time between AB, and third time between CB. Then again it is repeated. See again there is shift of disk between AC, between BA or AB, BC or CB, same thing, right? So we'll write a function. Okay, the now in while coming to the implementation part, we'll write a function to shift the disk from one rod to other, and three times that function will be called. Okay, and all the three times this function call is a recursive call. So it will keep on repeating until and unless there are no disk left, right? In tower A. So that's the whole idea or a logic behind the Tower of Hanoi problem. Now let's go to the implementation part of it. So now we'll see the implementation of Tower of Hanoi problem. So as a logic, I have explained you already. Now let's go to the Eclipse IDE directly and write down the code there. Okay. So I have opened the file over here. Okay. Already created a class Tower of Hanoi solution, and then there is a main method inside this. So we don't have to, separately maybe write any function or anything here. Directly we can come here and write down the logic behind the Star of Hanoi, whatever is there. So as I already told you that we have to write or do a function called three times for three different shiftings of disk from one rod to other or one tower to other. Okay, that's what I'm going to write down the code also. So let's see how it starts. So first we will assign how many disks were there. So let n contain the number of disks. So n is equal to 3. You can program for n equals to any number, guys. I have taken 3 in the explanation part, so I'm taking 3 over here as well. Let's have a function uh, shift disk. Okay, so shift disk is going to shift disks between one to other. So what will be the input to these okay, let's first write down this function that will make more sense. So let's come out of the main method, and here I'm going to write public static void shift disk. Okay, so suppose shift disk is the name of the function or a method. This will take first how many number of disk is there. So n3, that should be the input to this method. Next is the towers. Okay, let me represent those towers with characters, right? Maybe A, B, and C, or tower A, tower B, tower C, anything is fine. So let's have character TA representing the first tower, then char tower B, and then char tower C. Okay, so this will be the input, the three towers and number of disks. That's what is the only requirement or use in the Tower of Hanoi, right? Now the condition check is that if n is equal to 1. Okay, in that case, if there is only one disk left, then what you have to do is that disk should, the last one, right, that should be shifted from A to C, and that is it. The last disk I'm talking about, the last disk left, then it will be shifted from A to C. So if n is equal to 1, then you have to call, or you have to just print that disk is shifted from A to C. So disk is shifted from tower A to maybe tower C, right? The last disk I'm talking about, only one which is left. So you have to just shift from A to C. Else what you have to do is, okay, what is giving error? Okay, yeah, there should be one more plus here. Fine. So else, what should be the condition? That if it is not the last disk, then the intermediate operations has to be done. That is shifting, like A to C shifting is done. Okay. Now other intermediate shiftings were B to C and A to B. Right. So let's do that and call the function for that. So you have to call disk, yeah, correct spelling. This is for n minus 1. If there's one less than the total number of disks, then in that case you have to shift from, or call the recursive function from tower A, and the shifting will be to tower B using tower C, right? So this is one shift where you have to shift from, okay, this will be B. So you have to shift from A to B. So A to C is already done here. In this condition it is checked. Then it is, you have to shift from A to B by using or making use of tower C that is there. Next, again you have to, let's print also, so that we can understand that what exactly is happening. So here it is going to shift uh, disk. Okay, let's print the number of disk, that is n, from the disk number, that is n, right? 1, 2, 3, which I was numbering there. So disk from tower A is shifted to tower B, right? After that, again shift disk will be called for the last operation, that was, again this will be for n minus 1. Last shift will be from tower B to tower C through tower A. Okay, so this will be the last call to this function, and then closing of if and else loop. Okay, so this should close over here. Yeah, this closes here, this closes over here, and this closes the overall function. Okay, so you can see, guys, there were three operations mainly, right? Shifting the disks from tower A to C, from A to B, and then again B to C. So these three combinations are only repeating again and again. If there are like n is 3, then it will repeat 2 times maybe, and if it is more, then it will repeat more times. But the overall process remains the same. Okay, the combinations of towers which are used for shifting the disk remains the same. So that's it about the complete program. Now let's call the function. Okay, so I'm going to call it here shift disk, and let n, that is 3, be the number of disk. Then next will be your tower A, or tower A. Then next is your character again, tower B. Then next is your tower C. Okay, and call to this function. Okay, it says 1 second. Okay. Let's have one. It's a character, right? So we cannot have more than one characters here. It should be only one character. So that's the issue. So let's shift that from this to that. Now let's see what the output is. Is it the same which we, encountered? Okay, it says there is an error. Let's fix that. Okay. So you can see here, and let's match it if it comes the same. So first shift is from A to C, then uh okay, it's not writing disk number. 1 second. Should be disk 1 is shifted from tower of A to tower of C. Disk. Okay. Let's give space over here. Okay. Just a second. Yeah. Okay, now it will make more sense. Let's see the output. So disk 1 is shifted from A to C. That was our first step. 2 is shifted from A to C. 1 is shifted from C to B. Then 3 is shifted from A to B. No, this is not the output. It should be disk 1 is shifted from A to C, correct? Disk 2 is then shifted from A to B. It should not be A to C, right? Okay, then there is some mistake here. Let's try to fix it and figure it out. Okay, so what's the issue here is that let's check. So disk 1 is shifted from A to C. Okay, then again it is called for A to B through C. And it print disk N from is shifted to tower of B. Okay, no, this should be tower of C. Now let's see if it gives the correct output to us. Let's check. So disk 1 is shifted from A to C, 2 is shifted from A to B, correct? Then disk 1 is shifted from C to B, and 3 is shifted from A to C now. So 1 is shifted from, yeah, correct. So you can see here that the combination is A to C, A to B, and then C to B, right? And they can repeat it, A to C, B A, B to C, then again A to C. So this is what I was talking about, right? Three combinations, the disks are moved in a certain way. So it is nothing but the implementation of Tower of Hanoi is very simple, guys. You just have to do a recursive call over here for the method again and again, being very careful and analyzing this pattern. So as we analyze this pattern, there is movement of disk between AC, AB and CB. Again it repeats AC, BA or AB, either of it, right? But there's a shift of disk from either of this only. Then BC and then AC, right? So this is what has to be done. You can see the recursive call to these functions has to be made for movement of different disks to different towers or different rods. So now this concept of Tower of Hanoi uses dynamic programming. So you can see here that it explores the best possible output or optimal solution out of the all possible solutions, and then it gives you the final result or conclusion. And that's what the logic behind dynamic programming is all about. So that's all in the implementation of Tower of Hanoi using dynamic programming. So now let's summarize the session. We discussed about Tower of Hanoi problem, the most famous mathematical puzzle. What is the basic concept or basic arrangement setup of the complete game, and what is the final result we should obtain was discussed in this session. And then we understood the feasible solution for solving this puzzle. We went ahead and implemented this concept using Java programming, which was a very easy and most efficient optimized code written for implementing the Tower of Hanoi problem using Java code. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments.